Okay, ladies and gentlemen, it's a beautiful day here in East Jackson High School on a Thursday, the 29th of August. Almost the 30th. No, it's the 30th. It is the 30th, not 29th. My bad. Almost the 31st. Almost Labor Day, folks. We have a lot to be thankful for. This weekend, our glorious dogs will take the field against Austin P. And ladies and gentlemen, it'll be a great day in the state of Georgia. Okay? Now, we going to the fair, ladies and gentlemen. To the fair. Now, you and your friends go to the state fair. It costs you $6 to get into the fair and $2 each time you go on a ride. Consider the relationship between the number of rides and the total cost. Ladies and gentlemen, we have to identify who our X is and who our Y is. So who do you want to put as your X and who you want to put as your Y? See. Shh. You're missing the boat. See, I need a word. See, because this is a sentence. It has words in it. Huh? Rides and what? Costs. Now, Mr. Palmer, where did you get that? Listen to me. Number of rides and what? It's right there. It told you. So if it told you, then you need to be aware and do that. Now, ladies and gentlemen, what's the first data point I need to put in my table? Huh? 0, 0? Y'all agree with that? Yes or no? 0, 0 is what the young man said. No, they don't agree. Anybody else got one? Go. No, sir, not for this one. It's not. 0, 0 is not the right answer. 0, 2 is not the right answer, ladies and gentlemen. 0 what? 6. Why is it 0, 6? Hey, guys. When you read this, it's called reading comprehension. So listen to me, young folks. Pay attention right here. When we walked through that gate, before we could walk through that gate, ladies and gentlemen, to have the privilege to walk through that gate, how much did it cost us? That's exactly right. It cost us $6. Have we even rode a ride yet? No. There you go. Yeah. We have 0 ride and $6 cost. Thank you for allowing me to come in. I just paid you $6 for that. That's okay. So, when we get in the park, how are things going to change? So talk to me. How are things going to change? I'm doing what? I'm paying $2 for each ride. So when I go to my first ride, what is my total cost? Now, nope. How did you get 8? That's right. See, my cost is going up by how much? $2 for every ride, right? $2 for every ride. So, we can have 5 rides and we can have a total cost. Now, ladies and gentlemen, if one ride is $8, how much is 2 rides? My total cost of cents, $2. I mean, 10, right? What about 3 rides? 12. would you like to stop and turn all the way around? Those seats are designed for your buttocks to sit just like that. Sitting any other way would not warm the seat up, and 2, it will throw your alignment of your back out. So for the safety of you and others, please sit correctly. Now, if I'm at 12 and I go right again, now it's taking my cost to what? 14. Good. If I ride another ride, it's going up by how much? $16. So I get in the gate and I've ridden 5 rides. It's going to cost me $16, right? Huh? Well, it is if you ain't got it. Yeah, I mean, if you ain't got $16, you ain't going through that gate. You ain't riding right. That's a lot of money. I know. So, your friends, all right, your friends are not going to hang around too much for people that freeload off of them. You ain't going to have no friends. That's my public service announcement number 398,000. Now, I need to know, let's go ahead and write the equation. Since we are so in tune about writing the equation. Go. We'll give you 10 seconds. Go. Write the equation. Ladies and gentlemen, what is the K here? The change in Y over the change in what? Which is nothing more than what? 2 over 1, right? So when I write the equation, we go, okay, what goes here? Right, that's the K. Now, all right, when we write that, we have to consider, is that it? Or do we need to add something or subtract something? Well, let's check it. Let's pull a value, an X value. Let's pull 0. What's 2 times 0? 0. But what should I get out? So if I'm at 0 and I need to get out 6, what do I need to do? Oh, I had 6. Now, let's check it again because, we may have made a mistake. Okay, I've made mistakes all the time. So, no. I'm pretty sure, ask my wife. I make mistakes all the time. And if you're in here long enough, you'll see me make mistakes up here on math, on some calculations. Because my brain will go like this, and you'll go like that. And you'll be like, where'd you go, Palmer? And I said, I don't know. So, anyway. Guys, is there a correlation between... Well, let's do this. Let's check it. I said we was going to check it. 1. 2 times 1 is what? Plus 6 is what? Oh, I needed 8. I got 8, right? So the equation is what? Check. Good, right? So, let's do this. Is there a direct correlation? Is there something about that 6 up in the table and that 6 in the equation? Yes or no, ladies and gentlemen? Yes or no? Raise your hand for yes. Okay, raise your hand for no. All right, raise your hand if you don't have a clue. Then pay attention. Uh-huh. All right, now. Why'd you say yes? Right here. Why'd you say yes? Shh. Come on, Bradley. No, come on. Share your thoughts. Even if it's, listen, share your thoughts, even if it's wrong. It's better to be wrong and share them than not be wrong. And not share them and still be wrong and not be able to change it. Okay? So let's go. Oh, come on. Come on. All right, go. No. Do you see 0, 0 up there? No, sir. I don't see 0, 0 up there, so it doesn't cross the origin, does it? Okay. Guys, before we even ride a ride, how much does it cost us? That's it. So let's look at this equation. If you have to add or subtract something, it is happening when you've done nothing. Does that make sense? When you've done nothing in your scenario. If you have to add or subtract something, that's when you've done nothing. It's when your x value is 0. That's right. So when you see your x value 0, if you'll look to the right of it, if it has another number besides 0, then that's what you're going to add to your equation. Guaranteed every time. If you go back and look at your examples that you had before, that's 0. So if this is 0, I'm good with that, right? But it's not, it's who? It said, hey, you haven't done anything, but you at $6. Does that make sense? You at 6. So when you start to do something, you have to account for that $6, right? Okay. So that's what it's saying. Now, if we go to graph this, and hopefully you have, you could go rides, and then what? And then you make that 0. Let's make that 2, 4, 6. You got your first point right there, right? Now, what axis, I want to look at this. What axis is this? The y-axis. So wherever it touches or crosses, that's what you're adding. Every time. So it crossed at what? Or is that who? 6. Did we add 6? Yes, we did. Okay? So you got to make sure you're good with that. Any questions on that? So let's go look at this one. You could finish graphing it. It'll go up 2 and over 1, up 2 and over 1, right? Now, what is the rate of change in this problem? What's the rate of change for that problem that we just had? Okay, guys, listen. We have identified K. We have written equation. We have looked at the rate of change. This is just asking you, can you answer a question? What is the rate of change for the previous problem? 2. It's 2. Now, what is the y-intercept for this scenario, for your graph? Where do you see your y-intercept? In the table and then in the equation. Where do you see it? Well, in the table, we see it where? When x is who? In the equation, we see it what? Whatever is added or subtracted. Does that make sense? That's the y-intercept. In a graph, we see it right where? Right there. The point that is on the y-axis, right? Yeah? So, let me ask this. Oh, you want to know what your quiz looks like tomorrow? Just like this. So, if you can't do this, if you're like, I'm tired, I'm sleepy, then you're going to fail it tomorrow. So, this is your opportunity to get your unknowns known. So, please, by all means, don't answer my questions. It will not benefit you, right? Yeah, don't be facetious like that. Come on now. Let's go. How would you change the context so that the relationship between the total cost and number of rides can be modeled by y equals 2x? What is it doing? Go. That's exactly right. If I don't charge for entry, if I don't charge the $6, then 2x takes care of my scenario because it's $2 per ride, right? Does that make sense? $2 per ride. Now, how would you change the context so that the relationship, part D, between total cost and number of rides can be modeled by the equation y equals 6? Go, Leo. Yeah. Y equals 6 means your only cost is how much? $6. That's exactly right. So, when you see Y equals, is there an X there? No, X is the number of rides, right? So, we're not even considering how many rides you pay $6 and you can ride anything. That's what part D is, right? All right, any questions? All right, flip the page. Yeah, hold. Yeah, work my problem. You work my problem, we check it, then you can go. You got 2 minutes. Go. Come on now. Now, let's look at the problem. We're taking a road trip, right? Okay. You start the day with a full tank of gas. Huh? Oh, sorry. You start the day with a full tank of gas. Your tank holds 16 gallons of gas. On your trip, you use 2 gallons per hour. Consider the relationship between time in hours and amount of gas remaining in the tank. So, young folks, what goes right here for your X label? No, you're not understanding what I'm asking. What goes for your X label? What? Hours, right? Time, right? It's time. Now, it's in terms of hours, right? Okay. What goes in your Y's? Yeah, gas. It's in what form? Okay. Once you identify that, does that help you to help fill out the table? Should be. Okay. So, I'm going to go 1, 2, 3, 4, 5, and what? All right, so what do I do over here? For the first hour, how much gas am I using? It'll be 14. So how did you get that? Well, let me do, let me do something. Sorry. I started at 1. I should start at what? Yeah. Yeah. At 0 time, how much gas did I have? 16 gallons. That's right. At 1 hour, how many gas? 14. How did y'all know that? They're using how many gallons per hour? 2. That's exactly right. So it's going to decrease. It's a -2, right? All right, at 2, that'd be what? 12. At 3, that'd be what? 10. 4. 5. Okay, so how is we're going to change away from K. Well, hold up. Let's make sure we're good on our rate of change. What is our rate of change? -2 over what? Which is what? -2. So Y equals -2 what? X. Now, guys, do I add anything or subtract anything? Why am I adding 16? Yeah. -2 times 0 is 0. But I need to get 16, so in order to do that, I got to add, right? Huh? Excellent. That's a good job. Now, listen up, young folks. Do you see that point? Is it proportional? Why are they quick to say no and you quick to say yeah? For gentlemen, for it to be proportional, it's got to go through the origin, 0, 0, and it has to have a constant rate of what? So it's got a constant rate of change, but is it going through 0, 0? It's going through 0, 16. So no, it's not proportional. But does it have a linear relationship? Does it have a linear relationship? Yes or no? Yes or no? How do you know? Because it has a constant rate of change. A linear relationship means, ladies and gentlemen, it means that there's a constant rate of change, which means that when you connect the dots, it'll form a straight line. Okay? Now, it doesn't necessarily have to go through 0, 0. It just has to have a constant rate of change. That's the minimum. Okay? When you graph this, look, when you graph this is what you got to make sure you understand. Let's say 16's up here. That it's doing what? It's going down, right? Now, I didn't fill in the rest of it, but your graph ought to go down from left to what? Right. You understand? Any questions? No good? All right, so let's go answer some questions off this. What is the rate of change for this problem? -2. Where do you see the y-intercept on the graph and on the table? When x is what? Yeah, when x equals 0, you have the y-intercept, right? You got to make sure you understand that. Now, look at how this part C was answered. Do you agree with it or not? Said, how would you change the equation if your gas tank held 18 gallons and used 2.5 gallons per hour? But your 2 would go from -2 to -2 point what? And your 16 would go to what? There you go. Ladies and gentlemen, let's get you working on your homework.